Welcome to Science Buzz Cafe number 167, I think. Yeah, is that right?
That's how you
Yeah, only. It's almost 4 years. Thanks to Robert Buzz Porter, who put the buzz in Science Buzz Cafe, and the mad in Mad Science, actually, too. You've heard of Mad Science? We've announced that. It's
Then Buzz talk.
yeah, whatever it is, it's whatever's on the edge and that we can't quite call science, maybe. And we have a Mad Science Cafe in 2 weeks, so I want to welcome you to that. What are we talking about? Oh yeah, nuclear. Nuclear madness or nuclear necessity is kind of the title. So we want people to have their opinion, and we'll have a little presentation in 2 weeks at Coffee Cats. It's more of a, what do you call it, more of a forum where we're going to have a few short presentations and then hopefully allow people to say something. Not much. Either side, you know, so please, that's the...
Just remember that nuclear power is like sex.
How is that?
It's a dirty job, but somebody's got to do it.
And if it goes wrong, your genitals will fall off.
Oh, God.
So, females only to that one, eh? And next week is a little unusual too. It's at Coffee Cats and it's Shakespeare
Oh, well,
and the science of the time. So it's with Jay Simo and crowd. And so that'll be a little different. It was fun last time we did something like that. What did he do?
great. That was a
I thought it
great.
was Da Vinci.
Oh no, it's Da Vinci. Right, sorry.
The last time was Shakespeare.
Last time was Shakespeare. This time is Da Vinci, who you've all heard of, I'm sure.
The food is better.
Yeah. What?
In Italy, the food is better.
Okay, yeah, you got a point there. But anyway, what has that got to do with tonight? And thank you for the $4 that some of you donated. I appreciate that. It helps. We do have expenses. You know, we have to buy Robert a wine. Did I buy your wine?
Threw in the
Not
room.
yet.
And you, well, Terry.
Me?
Terry, you can introduce yourself because you're famous. So please, Terry, let's go for it. Put it on, put it on. Do we have everything?
I come here for self-flagellation and flagellation by Daniel. Thank you for showing up for such a mundane subject, you know, I've talked about plate tectonics and all that stuff. Hawaii just happens to be a place that I love. I've been there a number of times. And there's some very, very interesting things about the geology there that not many people know about. And so tonight we're going to kind of cruise along through some information that I have gleaned from my travels and my readings, all the readings. And we will take a little trip around the island, the Big Island mainly, and talk about some of the things that have gone on there. This is a shot of the one of the latest eruptions. I remember, when was it, back in early April, I guess, we started suddenly hearing about these big eruptions in Hawaii. And this was the East Rift Zone, the main volcanic area is a crack in the volcano Kilauea, and it extends right down towards Hilo, which is right about there. But it has been erupting along this zone for 30 years now, and it just had a renewal of its eruption, and it got everybody excited. And there's some beautiful pictures on the web and stuff. So I just downloaded this one here. It shows the crack right here with spots of magma coming up. These things form a little thing called spatter cones, which are like kind of mini volcanoes, and then they flow out into lava here, and these are lava flows mostly. Pohoyoi, we'll talk about Pohoyoi later. But you can see it going down into another crack, falling into another crack right here. And so that was kind of a cool thing I thought that might be interested in. And so this is what people think about when they think about Hawaii. But there's a lot more to the Big Island and all of the islands that This is what we call Big Island right here, Maui right here, Oahu, Kauai. The other ones have other names. There's one called Molokai right there. Okay. You know, there will be Lanai. Lanai is particularly important on the 600-foot level of Lanai. There is a funny rock. It's a conglomerate of chunks of limestone, which are basically coral reef material that were deposited up there about 500 years ago. And so the interpretation of this is that a big old wave hit this place and grabbed up all this stuff and threw it up on top of the mountain. So, you know, the people started thinking about things like this, and they said, what the heck is going on out there? There are secrets to the heights of many of these places that we'll explore. Let's see. The Hawaiian Islands get younger as you go to the south and east, and this has been blamed on a hotspot. And basically, the idea is that the plate itself is moving over a stationary hotspot. I don't know if you can see me. Ow! I'm burning. Like this, and with the progression of seafloor spreading and the ocean floor over the stationary hotspot, then one by one these volcanoes have come up. The active volcano now is Kilauea, and that's right here. And but there's another volcano right here underwater called Loihi, L-O-I-H-I. And in another 1,000 years or several, maybe 20,000 years, we expect that. It's erupting right now. We expect that to come and rear its ugly head and suck Bob Porter down into its depths.
To what?
Are they getting bigger as they get younger? Or is that just coincidence, or is that even true?
Well, they look like they're getting bigger. The Big Island is the biggest island, but it has more volcanoes on it. And maybe this has something to do with fracture systems underneath that has more conduits for the magma to come up to the surface. The idea is that there's a mantle plume underneath here. And so we're going to talk about a bunch of different things. And some of these things we won't talk about. But if you want me to talk about them, I will, but you know how it is. We'll get to them too. We'll talk about shield volcanoes, the very low profile of these volcanoes looks like a shield. And that's because the lava that comes out is called basalt, and it's very, very fluid. And so it has a very low angle of repose. This, as you can see, the lava is here. Talk about mantle plumes, because we feel that plumes in the mantle or hot material in the mantle is pushing up underneath this area and causing this hot spot. We have inclusions of mantle material from hundreds of miles down that are present in some of the lavas, so that we know these things came from deep down there. Lava flows, we'll talk about that. Phreatic, water explosive eruptions. Fountains, collapses. Sometimes these things will just collapse, and we have a really neat video of that. And lava tubes, where the lava will actually run underground in a cave for 30 miles down the mountain. And there's a lava tube. We actually got a tour of one of the biggest lava tubes there. It was really cool. And the stuff we call pillow lava, which is fun stuff. It's materials that were erupted on the ocean floor and have rounded features. There's non-volcanic geology too. There's always earthquakes. The earthquakes are set up by the intruding magma in the deep parts of the earth. Tsunamis, we just had a tsunami there that knocked on the door of Hawaii from Japan. Mega landslides, these are landslides where whole sections of islands have collapsed. And we think that maybe one of these things caused the conglomerate that we see up on the top of Floyd. All kinds of uplift and erosion, there's some spectacular erosion, waterfalls, beaches, reefs, canyons, all kinds of good stuff. And for some reason this isn't coming up, but there's other aspects. The trade winds come through here. There's something called fog that is a real threat. If you go out to the island and suddenly there's a change in the weather and you get this fog, it's actually volcanic fog, and it has high H2S content. And we were actually booted off of a couple of the display areas in the park because they basically the air was too heavy with H2S. We had friends. I stayed with a bunch of friends there. That's all nice. Flowers, jungles, landscape, food, mercury-tainted fish. I didn't put anything in about this, but mercury-tainted fish, the emanations of gases and fluids from underwater eruptions put mercury into the seawater, and that gets concentrated in the fish. And my friends got severely mercury poisoned as a result of this. And you go there to eat the fish. I go there to eat the fish.
But it's natural.
Yeah.
Yeah.
It's organic.
These guys are back to the landers. There's hippies, communes, and it's very sophisticated off-the-grid life.
Like Mendo County.
Yeah, Mendo County. Let's see what we're doing here. Okay, well, this is a little primer on what makes geology work. These are called motions in the mantle, and these are down motions, and you can see some things. This thing right here looks very phallic, but it's called a drip. Okay, stuff. It's a drip. This kind of big area here is a subduction zone where cooler lithosphere, harder lithosphere, dives down into the hot mantle. And these are the plumes. These are mantle plumes here, where they're coming up. They look like a forest of trees and stuff like that. Let's see if we get this thing moving again.
How was that determined?
How was that determined?
Sophisticated seismic studies.
Yeah. These are done by seismic tomography. And we talked about that last time, so consult your notes from last time. But no, what they do is a CAT scan of the Earth using earthquake waves. And what happens is you focus on a particular area, the waves that go through there, you study them, and they give you an idea of the strength of the rock. Strength of the rock gives you an idea whether it's molten or hard or whatever. These are molten plumes, they're called. They're called mantle plumes, and they're pushing their way up from the outer core. This is the edge of the core of the Earth. And this whole area up here between the core and the surface is basically in motion as a result of these plumes.
How deep is that?
How deep is that? The core is 2,000 kilometers down. Where's Hawaii on that? It could be sitting right up on top of one of these little guys. I'm not really sure exactly where it is. See, it's kind of maybe this one right here. This I haven't really figured this diagram out. I was desperate to get things together to. Okay, the origin of mantle plumes basically is that the Earth, if we look at the core of the Earth, it has hot material that pushes its way up, and it pushes its way up towards the surface. It curves around, and gives you this plume kind of activity. And notice that it goes up and it curves down. It's a really pretty complex pattern. But these, again, are imaged by the work of seismology, and we get an idea of what these things are by looking at seismic velocity inside the Earth. We'll see if we can get that going again. Come on. There we go. Just to give you a treat. I'll show you this twice. This is the inner core. It's very hot, and hot material at the core mantle boundary right here is levitating. It's less dense, so it comes up. And
How hot is it compared to the sun?
How hot is it compared to the sun? It's not nearly as hot as the sun. How hot is the sun?
10,000.
10,000. These things are, this stuff is probably under pressure. It's very high pressures down there. It's probably molten at 1,500 degrees centigrade. Something like that. Yeah.
If the core is involved in this, are those plumes enriched with iron?
They are. Yeah. Well, there's a lot of iron as you go down into the Earth, and the core is just the outer core. It's the very edge of the core. The core mantle boundary is kind of a battleground that's going on, and there's plumes coming up, and there's drips sinking down, and these things go back and forth and back and forth, and all of a sudden, like here we go. This is my little plume here comes a blob, and this blob then would be just slightly less dense than the material underneath it, and it would rise up towards the surface.
What is that? What do you got there?
That's a thing called a lava lamp.
Why do you have
A
that?
lava lamp?
Because it shows convection.
I want one.
It shows convection,
Is that real
and
lava?
it basically shows
No, but I
how
need one.
density differences.
I know.
Yeah, it's a function of temperature. How density differences driven by temperature are making these plumes and movements and things like that under the surface of the Earth. Is that cool or what? Okay, this is the view of the Earth and the northern part of the Pacific Ocean, and you can see the Hawaiian Island chain down here, but you see also that it's the end of something called the Hawaiian Emperor chain. It starts right up here in Alaska, right at the Alaskan the subduction zone. And this is the Emperor Island. Here's the Emperor Seamount chain up here. They're called seamounts because they're mountains under the sea. That makes sense, doesn't it? And then the Hawaiian Ridge down here. Now we think that this is the result of a plate. This plate moving over the island, a stationary hotspot. There are other ideas. Some people think there's a propagating crack that's causing this, and I thought it was a little bit too complicated for me to figure out. At any rate, right here we see there's a bend in this ridge at right here, and this is at about 42 million years. And what has happened, we think, is that the plate changed its orientation of movement about 62 degrees at this point in time, and now is going in this direction. So the plate was going in one direction, and then it moved in another direction, and the plate, the result of this was the etching of the plate motion on the ocean floor.
Have they been able to correlate any causative factor with that happening at that time, like some other plate bumping into it or something?
Well, that's one of the problems. They haven't really been able to figure out, what might have caused that. It does coincide with, however, a major reorganization of plates in the Southeast Asia and India. It's when India, 42 million years ago, was when India bumped its way into Tibet and started all that uplift and stuff like that.
Could shock waves have propagated through the earth and come out in the Pacific?
I don't understand your question. Shockwave.
Shock waves, from some kind of, something from India hitting the continent there. I know it's a very slow process,
Yeah,
but.
no, it's just
Okay.
much too slow.
Okay.
Much too slow. You're way off the bat. 10 demerits.
I'm not a geologist, that's why I'm here.
Okay, we have earthquake activity.
No such thing as a bad question, well, maybe.
No, this guy. Keep an eye on him.
Oh, he's my favorite guy, be careful.
Okay, this word here says Halimau, and that is the main volcano inside Hawaii Volcanoes National Park. And you usually would see little earthquakes here every once in a while, but this is a massive earthquakes. And this massive earthquakes, this massive earthquakes is what's called volcanic tremor. And basically what's happening is the magma deep under the surface is working its way up, and it's shaking the earth. And it's shaking the earth at a very low frequency. And so as a result, you should see little pops and things like that of seismograph, what you see on seismograph. We're not seeing it here. We're seeing the whole earth shaking as a result of this.
You only have 3 points there, but they look very regular. Is it?
Regular. What do you mean regular?
Well, periodic.
Oh yeah, those are the timing.
Yeah.
That's the timing. Yeah, that's every minute it has this little timer.
So is that near Kilauea?
So would
That's up on the summit of Kilauea. Halimau is the Halimau fire pit, which is the big volcano that is right at the top of Kilauea.
And as time, if you were to look at it for larger periods of time, the period would be about the same.
Yeah, for all this, as long as.
Clock into the signal. That's what you're looking at there.
Yeah, but I assume the change in amplitude means that there's some periodic.
It's a reference.
Oh, no,
It's
it's,
a reference.
it's just restless, yeah.
Okay.
Well, this is just another diagram of plumes and stuff, so to give you a static idea of what's going on down here. But here's the outer core, the lower mantle here, and this is partially molten, but this upper mantle part here is very partially molten. It has a name, and this is a good one for spelling bees and stuff, for those of you who have spelling bees. It's called asthenosphere.
Oh.
Asthenosphere. And that is, that means more fluid level. And this is where the plumes kind of mushroom out and they lake out and stuff like that. And they form, this is a hot spot right here. These are something called large igneous provinces, LIP, this is very important areas, and some plumes.
Where's the Moho?
The Moho is right at the bottom of the crust, which is right, this is right there. And that's the Mohorovičić discontinuity for those of you. Yeah, MOH. For those of you who had geology way back when, Mohorovičić was a cool guy. These are the worldwide distribution of hotspots. We have several here in the South Pacific, as well as Hawaii. They also have trails very similar to Hawaii. So it sounds like that all these things are fairly stable, although they may not be. There are people who argue that they're not. But basically, they're stable. There's a fixed hotspot. The crust moves across that hotspot. And here's Hawaii, Maui, Oahu, Hawaii, as little blips and pimples that have come up from the eruptions of the material from down in the plume. Yeah.
I've heard that the Yellowstone hotspot is
Yeah.
very explosive when it happens. Very bad news for anything within hundreds of miles. Why is it so, do they have any idea why it's so different from the Hawaiian one?
It has a lot more silica in its component because it comes up through the crust. And this silica makes the magma viscous, much more viscous.
So then-
And so it holds more, and it's cooler, it holds more fluids, and it can build up more pressure. It's like a Heimlich maneuver, right? I got a joke about that. But the Heimlich maneuver basically that's what happens when you get a big clot of stuff, very viscous fluids from the lava pushed out very rapidly. St. Helens was an example. Long Valley was an example of that. 1,000 square cubic kilometers of material came out of Long Valley Coal north of Bishop. Every time I look up from my house in Benton, I say, whoop, I wonder if that's going to happen again. But the one in Yellowstone hasn't erupted for 200,000 years or something like that, so we're not too worried about it.
What's the difference between that and Long Valley, if one's a hot spot and one isn't, in that?
Yeah, there is a
Why is
difference.
that?
That's very good, very good.
So that was a good question?
That was a good question. She gets 10 merits for that one.
Because one is just coming up.
Yikes.
Okay.
Because that wasn't important.
Maybe Terry gets a demerit there.
Dancing around here.
Oh, really? Well, we'll have to
Okay.
have words about that later.
Computer went back here.
So the conduit.
What were we talking about?
Simulates, siliceous materials.
Yeah,
The
by
conduit
1
still
foot,
yeah.
Incorporates.
Yeah, it still incorporates it, yeah, it's more, it changes the chemistry
Yeah.
and makes it much more
Why are
volatile.
some dormant?
Things that make explosive volcanic eruptions are viscous lavas, fluids, and sometimes just any kind of lava hitting a pocket of water, something like that. We think that there were some explosions in Mono Lake area that were as a result of a explosion. These explosions were as a result of material magma material hitting water. This is looking straight down at the Hawaiian hotspot. These little square things here are ocean bottom seismometers. And this is something they've developed in the last 20 years to look at very deep structures. This area right here is very hot. This is, and this is at the depth that you're looking at here is 1,200 kilometers. 1,200 kilometers, there's a little bullseye of very hot magma sitting down there, and it's basically feeding the hotspot. Okay, we're going to look at some rocks now, I think. Yeah, look at that. Yeah, that's why they do these things. It's pretty sharp. There are many cool places to go in Hawaii. And some of them you have to hike to, some of them are four-wheel drive places. But this place, which is green, is called Green Sand Beach. And it is probably one of the coolest beaches out there. You have to either rent a four-wheel drive 2 miles, or hike out there. My girlfriend and I hiked out there this last time and had a wonderful time. But you see how green it is right here. The green is from a mineral called olivine. Olivine is a silicate mineral that's present in basalt, and you can see the green kind of coming down here. But this forms a little pocket beach right here. It's out of the wind, which is nice because it's usually usually windy out there. They actually have a big wind farm out there too. This is on the Big Island, yeah, down near South Point. Big Island Revealed is the book. If you need a book, that's the book. It's got all kinds of neat tips about. And there's the green sand. You can see the crystals of olivine right here. And these are part of a cinder cone that actually emanated from a lava tube that was flowing into the ocean. So the lava tube was like a tunnel underneath everything. Okay? And at this particular spot, it broke through to the surface and started spewing all the stuff out of the surface and gave us this big pile of green olivine and layered stuff. It's a really cool little beach. People do crazy things there. You see the layers right here of the ash. Right, yeah, that's a good 50, 60 feet down there.
How much olivine?
It's percentage-wise, it's almost 100%. Lava trees. Lava trees are a cool little thing. There she is. Better late than never. There's a whole field of these things. I'll show you some more here. And these things are basically lava flows that flowed around big old trees. I forget the name of the trees, but there are trees and trees there. And it flowed all the way up and covered the top, and then the lava collapsed around it and left the tree encased in lava. So there's a whole great field of these things out there that we checked out. You can see these things. There's one there, one there, one there.
How tall?
They're about 15, 20 feet tall. It was actually a state park near Pahoa, which is on the kind of southeast side of the island. Pahoa is where I hang out most of the time because I've got friends there. But at any rate, these were up on the volcano themselves. But there is a state park called the Lava Tree State Park.
That makes sense.
Get really funny with these. This is Holly Mau Fire Pit. You can see it right here. It's kind of a crusty day when we were up there, and about 5 minutes after this picture was taken, the gendarme said, "Get out of here, there's too much SO2 in the air." Had a little meter in their hand, and they were kind of running around and telling us that we had to leave, so we left. But it's a big problem up there. Sometimes if it gets too bad, I had some friends who were there, and they had to leave the park. They had to leave the place because of this stuff in here. Bad stuff in here.
Do you get acid rain there at all?
Acid rain, yeah. H2S gets makes sulfuric acid basically, and there's a whole desert. One of the dichotomies of mainly the Big Island is that you get up to the volcano and start down towards the west, and it's all desert. It's a whole desert there, and that desert is because the rain stops there. It's first a rain effect, rain shadow effect, but also it is the effect of sulfuric acid and stuff like that. There were story goes, and it has been disproven, I think, but what the heck, it's a good story. That there was a battalion of warriors going over to sneak attack King Kamehameha, and they were tromping along around the volcano, and the volcano erupted and it fried them all, buried them. And there are footprints in the sand out there, and that's why people think that's true. But people just went back and they restudied this, and they think that these footprints in the sand were women's, and they were just, they were okay.
Okay.
Didn't find any bodies,
You were on vacation.
They were on vacation, or on safari, whatever. This is an innocuous looking hole here, but this right here was the spout of one of the most spectacular fountaining episodes of Kilauea, called Kilauea Iki. And I took a hike down past this thing because I'd never seen it. And this is what it looked like in 1999. It was probably one of the it's the most spectacular thing. That's a 200-foot high spout of lava there. And you can imagine sitting there at night, taking whatever stimulants you want to, watching this thing blow itself up.
Who needs stimulants?
Yeah, really, I mean, what do you know? And this is the lava plain that came from that eruption. And these are very flat surfaces. This is what we'll call Pohoihoi lava, or it's a very fluid lava. And there's a kind of a plain there that you could hike across. And I got caught torrential downpour out there, and had all kinds of implications. But this is the bottom of the Kilauea crater at Kilauea Iki. And really, really neat place. There are all these little spouts coming up here, various places. You can see lots of people on the trail, lots of reindeer. It rains a lot up there. This is looking from Mauna Loa, which is the big mountain there on that side of the island, looking down at the place that was erupting. This is Halemaumau right here, and this is the area we call Pu'u'u'u. Like that?
Okay.
Pu'u'u'u. It means home of the u'u bird. Okay?
Okay.
Pu'u'u'u. But at any rate, it's a really cool place. I don't know how this got in there. It's out of sync. This is a lava flow that went into the ocean. These are typical curved surfaces of Pohoihoi types of lava. And there's an arch right here. It's a really cool place. Okay, if you want to go tromp around on lava, you can do that now. If you're in the national park, they don't let you go anywhere near the lava. They have people with AK-47s out there. But the county side, which is towards Hilo, towards Pahoa, is open territory, and you can wander around out there. These are Pohoihoi lava flows. These are the one the slide I showed you before with lava flows, and this is basically what built up this surface. Yeah, Dick.
Yeah. About 7 kilometers down, southeast of the rift zone along the ridge, there's a sort of fault zone.
This is just a sec. This is a collapse of. This is one of the spectacular things. Time lapse.
You wouldn't want to be picnicking there.
Time lapse photograph of Pu'u'u'u.
Let's do that again.
It would certainly make me poo.
No, I didn't. No, this is from the web.
What's the duration of this time?
Like one day.
I think this is overnight. It starts at night.
Ends at night.
Afternoon when it collapses.
And then it ends at night.
And then it ends at night, yeah.
Yeah, just one day. Wow.
It's pretty cool.
Understand what
Basically.
Yeah, they know when that happened.
You know.
I don't know. It was sometime in early April. That was the.
This year?
This year, yeah. This latest eruption, yeah. There it goes. Boom. There's the loss. And it sank down to, something like 300 meters below the surface.
Wow.
So what do the birds look like?
They're, regular LGBs.
LBJs.
LBGs,
Little brown jellies.
LGBs. LGBs, you know what an LGB is?
No.
Little gray bird. Okay, this is the crack right here. You can see the eruption going along here, and then the crack continues. I'm still.
Get back, yeah.
The crack is propagating out here, and there's actually a video of the propagation of this crack that was beyond me to put it into the. I didn't want to excite you too much. You can see the lava coming out on the surface. And this is the lava at night going into the ocean. You can rent a boat ride for $100. You can go out there at 4 in the morning, and they'll drive you right up to the lava. And you can see these lava falls.
Terry, doesn't that lava often create HCl when it hits the water?
Oh, no, does it?
I believe it does. It comes with it.
Yeah, it smells H2S, yeah. This is a picture of the
All the sunlight, all the nice weather.
the lava flow going into the ocean over on the western, on the eastern side of Pahoa, a little town there called, well, at any rate, when you drive in towards the volcano from Hilo and Pahoa, you can drive right up to this place. And this is Halemaumau again. This is a different phase. This is actually, we'd gone down to go kayaking on the other side of the island, and everything was nice and quiet up there at the volcano. And we came back, and it was just, like that. And everyone's running over there, and the TV crews are out. This is Pahoehoe. Pahoehoe lava is ropey. It means ropey in Hawaiian. It's pretty. And it's very pretty stuff, yeah. But it's a very fluid lava. It's fluid because it has very few volatiles in it, very little gas, and it's a higher temperature than the other types of lava that you get. But at any rate, see whole fields. This is called lava, right here, and it's blocky kind of lava, and the Hawaiians named this because whenever you walked across it in bare feet, you went We've got to do that for years. This is a Japanese cemetery that was inundated in 1958 by a cremation. This is, well, if you go out on a hot day and you look at tar, and there's a crack in the tar, sometimes you see the tar well up here like this. This is a little fluid squirt of lava that's coming up. Come on. Whoop, sorry. Okay, this is the art show. Want to see an art show of Pahoehoe lava.
Wow.
These are just pieces of molten lava that have kind of moved around on themselves.
Is that true color or some kind of tinted black and white photos or what?
No, this is true color, it's basalt.
Okay.
So it's black, yeah.
But it's
This is what I call the tangled rope syndrome. This is molten right here. See the red right there? We call this the fish because he looks
Yeah,
kind of
it
looks
looks
like a
like a big
fish
lizard or something.
going along the top. Now we took a tour, took a hike up onto the where the lava was actually flowing on the surface. Turned out to be fairly easy to get to. But there's a little mound right there. This is a couple feet across. It's kind of small scale, but this is the molten lava coming. You can see it's red there, and it goes black as it.
How fast is that moving?
That's moving, flowing kind of generally. I'll show you in a minute. You'll get an idea. These are called lava toes. They're little
Toes.
loopy toes here. These things. And this is, we bring flowers to, hibiscus flowers for Pele. It's offers to, again, that's raw. Here's another one. That's the one I took, yeah. You got hibiscus about to be munched by lava.
Very nutritious.
Wow.
More toes.
What causes the different types of lava, you know, the or the rope kind or the flat kind, different temperatures of the?
Got different temperatures, slightly different composition of volatiles.
There's more quartz in that too.
There's more quartz in the
Yeah, that's what-
so it's a higher silica,
Oh.
and that high silica makes it lava. Okay, here comes the water. Here, this is the video right here.
Oh, cool.
We're all gonna die.
This is real time.
This is real time, yeah. Yeah, I was about 15 feet from this thing.
It was hot.
Yeah, was it hot?
Yeah.
Really fast.
I hear a windy sound. Is that from this?
There's some wind, yeah, there's some wind in the background on my microphone. On my
Like candle wax.
Nikon.
There's a bunch of candles. No, it did the same thing. Wait.
Yeah, we talked about various features of volcanoes. One of them is the lava tubes.
Love it.
And the lava tubes are basically caves through which the lava flowed. And it may have flowed several times, it may have flowed at several levels, but there's one called Thurston Lava Tube right up at Kilauea, and it's a very popular place to go. We think that it's connected to another cave called the Kazamura Cave. It goes 32 miles down towards, it's been mapped 32 miles down towards Hilo. And here we are in the cave. They gave us helmets and
So well.
we were on our best behavior. But we went through the cave, but all kinds of weird things. This is the cave entrance. You see it kind of curving around like this.
Yeah.
There's striations on the floor where the lava flowed and came around the corner here. But this is the kind of general shape. There may have been another level of lava up here for a certain period of time that flowed through this upper chamber. And it's a real kick to get down into this place. They do tours for $20 a head, which I think is cheap. This is little drips from the ceiling, drips of lava that when the lava level went down, it left these little drippy kind of things. And, this is
Is that a technical name?
Yeah, that's very technical, very scientific.
Here's someone for scale. You can see how big this thing is. This is another level up in here. See the upper level right here. And sometimes blocks fall down, things like that. It's
I don't think I want to
lava
go in
tubes are
there.
cool. This is a mushroom kind of shaped thing that came down off the ceiling, and nobody really knows how that formed, but it was kind of a cool thing. So I took a picture of it. Okay, lava goes into the ocean, and when it does, it changes, and you can get hot seething lava material going into cold ocean water. It isn't that cold, but it's cold, relatively speaking. And this is what happens. You get these big eruptions of steam right here. You can see a little bit of lava back in here. But the main thing that happens is that the lava kind of blobs off into these things called pillow lavas. These are pillows right here. These rounded things are pillows, and this is where
Let's begin.
You can see the ocean floor is just littered with these things. Pillow lavas are one of the main components of volcanic rocks in the ocean floor. This one happens to be at Shell Beach, right out here on the coast, where it was on the ocean floor at one time, and has subsequently been pushed up on land and eroded away. You can see it. And if you go to my website, terrywrightgeology.com, there's a field trip, a virtual field trip to Shell Beach. Wow. And you can check that out. It's also one to Bodega Head. So anything you want to know about the geology of Sonoma County is in there on the web. These things were first captured by divers, and this is kind of a fuzzy picture, but this is a blob of lava that is basically expanding, and this crack right here is an ever winding crack going something like that. And if I can get it together here technically,
That's so neat.
and this is what these things look like as they're forming. You can see that there's an expansion, there's a fluid. I used to show this Halloween
It's like a
time.
big area.
But these blobs, you see they're forming these big round blobs of
Right, but there's stuff pushing behind all the time, so it's.
Is that underwater?
Yeah, that's underwater, yeah.
Oh.
These are all underwater. These are scuba divers down there taking pictures.
That's pretty wild.
Why isn't that clouded by
There's a
steam?
flipper right there. Yeah, and there's a landslide of this stuff coming down.
Is it hot where they're swimming?
Yeah, it's warm. It's in the 90s. I think that's worth it again.
Terry, what's the scale on this?
It's about 3 or 4 feet across. 3 or 4. It's just a little too hot to put a ruler down there. But when
So
you see
is
the
it just-
flipper, you get the idea.
Is it just totally molten on the inside and then that
Yeah, and
outside
then it
gray
just kind
cover
of
is?
expands
What
and
is that
pushes
gray
outward.
stuff on the outside?
That's cool.
That's the
It's cooled by the water.
magma, Yeah,
That's the cool magma.
yeah. That's rock.
Super cooked marshmallow.
Yeah, in a horror movie.
This is
Rock,
real
just some
time.
of it's molten.
Real time, yeah.
Yeah.
Always believe me.
And hot and steamy.
hot.
Okay, this is kind of the scenic part, but this is Akaka Falls. These are lava flows that have a river that runs over them. It's one of the more famous waterfalls. I think it's 400 feet high. And it's a cool spot. There are beaches on Hawaii, and the whole kind of northwest part of the island is a plateau that was a large volcano that has been cut into, and there's a series of 6 huge canyons that kind of cut into this thing. This is Pololo Valley. It's the northernmost. It's near the town of Hawaii, and it's a very short hike down to this thing, and it's absolutely heavenly. It's a really cool place to hang out.
What island?
Big Island. There's a little pocket beaches, black sand with hippies on them.
Right.
This is one of the more famous ones right here. There was a drum concert going on when we were there. You know, there's all these hippies running around and clothing optional and all this kind of stuff.
Are they
Naked hippies.
Naked hippies, but
Are they indigenous?
I went out into the surf and got clobbered because I wasn't aware that there was a big surf warning out, and the waves were really big, and I ended up hitting a rock in my back and getting cut up. So it's a cool place.
Cool.
Yeah.
Take a little trip to the ER.
But you made it back alive to do your presentation.
Yeah. These are just some shots.
Proving that you can be an old geologist.
Waves are a big source of problems in Japan. This is The Wave by Hokusai, and you can see the size of this boat about to get upended by this wave.
Too bad the designers of that nuclear plant cluster didn't know this.
Yeah.
They didn't know that. Well,
They put their generators on the ground floor.
Yeah, there's Fuji.
That was really
There's Fuji
smart.
in the background
Oh my
there.
God, so much for nuclear.
But individual ones, so there are tsunamis, which come from earthquakes, and this last one that we had in Japan was a perfect example of that. But also, huge chunks of the islands have fallen away, and they have formed mega landslides. This is on Molokai, and it's kind of you see kind of a hook here, a vertical face, vertical poly, it's called. And when you look at the map of offshore of this area, here's this area right here, you see these big blocks, and these things are big chunks of Kauai and Molokai that have slid down onto the ocean floor. Some of them are big enough to be called seamounts. They're shallow enough to be called seamounts. So you don't want to be around, when one of these things cuts loose. But they do happen, and when you look around,
They displace a lot of water.
they displace a lot of water.
You say Kauai?
Huh?
Kauai? You said, or Molokai?
Kauai. I said both.
Both.
Kauai and Molokai and Big Island and all of those islands have these features. This is a little hard to see, but this, you see these chunks of stuff here. This is a conglomerate or broken up bunch of rocks that have coral. And this coral could only have come from the ocean. It's only about 400 years old, and this layer is only about 400 years old. So the idea, and this layer is 200 meters above sea level. So the thought is that
200-meter
there's
wave.
deposits of like this on Molokai and Lanai, And these things were from monster sea waves that happen as a result of these mega landslides.
How sudden do they think they happen?
How sudden? They must happen pretty suddenly because when you get a broken up bunch of rock like that, that's one of the main kinds of things that you see with a sudden deposit.
Can they anticipate, do they think they can anticipate?
They might be able to if they monitor cracks or stuff like that. Everything's so much covered with jungle and things like that.
So you were saying that the mega slide caused a large wave which deposited the rock.
Yeah.
But it wasn't tsunamis from earthquakes that caused the mega
Right,
slide.
exactly.
Or they caused the mega slides? They precipitated
No,
the
mega slides
Yeah.
are caused by basically the rock weakness.
Okay.
Erosion.
Is it also associated with activity?
I'm not sure. I don't think it is. No. Yeah, this looks like your eyeball, but this is a map that came out right after the Japan quake, where it showed the directions of the highest waves, and these things came out like this. Here's Hawaii right here, and the highest waves came something like that, and came right slammed into Hawaii, and there was tsunami damage done quite a bit on the Kona side, which is towards. You've all seen these pictures of Japan and the tsunami in Japan. But this thing also radiated out and caused damage in Alaska and all up and down the west coast, especially in Hawaii. Yeah. Those must have been pretty horrendous. This is a house that was belonged to a friend of mine that sat out on a little point in Kamehameha Bay, and basically got swept off its feet. It's still floating around out there, so if you need a house, go get a house. Yeah. The surf was really high when we were there. There's a lot of coral reefs. So coral reefs are part of the story. These are layers that kind of look like steps of coral reefs, but they form during times of stillstand of the ocean level during interglacial times, and so each of these things represents a period of time when it was pretty. The sea level was pretty much. So the way to look at these things is put your snorkeling equipment on, and this is yours truly.
Who's that guy?
Neptune.
You can see a bunch of snorkelers out here. This is the Kapoho Tide Pools, which is the best place on the island to go. We spent 8 days there. And coral, fish, lots of nice fish. What can I say?
Fish.
This is Waipio Valley right here, which was a big thriving center of civilization. Gardens and all that kind of stuff in there. And there's a very narrow road that goes down there. This is one of the more spectacular places. Again, on that side of the mountain, the valley of the island that has these.
Is that something that was wiped out in the recent tsunami?
No.
Okay.
No, this is on the other side of the island. The rocks even have their own mythology. These two rocks are reputed to be the place where a tribe of islanders were occupying a little valley here. And they saw these marauders coming in their big canoes across the bay, and they said, "Oh, what are we going to do?" Well, these sweethearts, this man and this woman said, "We volunteer. We will go out and we will turn them back." And so they went out and they turned themselves into rocks, and they all crashed into rocks. And that's the end of the story. Lived happily ever
Good
after.
plan, good
Yeah.
plan. Yeah.
Very smart.
Or ahoy hoy.
Wait, there's Cindy on the other side.
obviously, is the lawyer.
Okay, you know the Islanders
Mississippi.
spent a lot of time, a lot of downtime, kind of hanging out and making petroglyphs. There's one place where they have over 20,000 petroglyphs in this one particular spot. And you can see their typical petroglyph.
How old are they?
How old are these?
Yeah, those people.
I don't know.
No.
They've been there for a long period of time.
Well, how long is long?
1,000 years, 1,500, something like that.
Google it.
I don't know, I can Google it, yeah. You can see these little holes. You see these little holes here. These are places where they put umbilical cords in for babies.
Wow.
Save those.
Nene birds.
Nene.
Nene birds.
Nene negative?
Hawaiian native bird. I'm just going to run through these because I don't have much geology here. But that's all right.
One glass of oil.
This is called cat's whiskers. This is a thing called the green pond. It's in the core of a volcano, and you can swim here.
Oh, that's pretty. We've seen those around.
Orchids all over, yeah.
That's pretty amazing, wild orchids.
Orchids are my favorite.
This thing is like crazy. I'm crazy with this one.
What is that?
The ginger.
That's it's a ginger or something.
This talk is next month on the flowers.
What? This is our friend Judy in a hot spring. There's a little hot spring where you can hang out. These are. I told you I'd show you hippies.
Yeah, we're waiting. That's what I came
There are. Which one's you?
That's not tobacco.
Those are hippies.
They look pretty tame.
Lots of open air markets. Lots of back to the landers. These people are off the grid. This is what their place looks like now. Walk in. These guys are renegades from
Silicon
Burnville.
Valley.
Renegades of Burnville. Each one of these little white things out there, although we can't see them very well, are whales. There's a big whale migration that goes forth up there.
What kind of whale?
Gray whales.
Whoa, look at
There's a turtle. And there's a
headless Buddha.
This is Kamehameha's birthplace. This was his heiau. There's a lot of historical stuff. The Painted Church is a really cool place. It's got, and there are restaurants, and people lying down. Friends, countrymen. These are our friends that we stayed with. And that's the sunset. That's it.
Any questions or comments? Yeah, Dick.
Yeah, one big thing about Kilauea.
This is a comment, right?
Is a horizontal fault, and lava's coming up from below and pushing a whole section of the volcano out and making room for the lava. And it never gets stuck on that slide out towards the southeast. Then is when it's come over the top. So if you're ever buying land out there, you wanna be careful not to be along anywhere southeast of that rift zone, all the way out to Pahoa. I was out there looking.
Did you say Kilauea?
Yeah,
Kilauea.
southeast side of Kilauea.
And
Being
Hawaii.
slowly pushed out towards sea by this lava welling up and down below. And making space for the
Okay, no refunds. In the picture with the steps of the coral.
Yeah, right.
It looks like there was a fairly sudden change in the rock structure or something, because coral tends to grow close to the surface of the sea, as I understand.
The sea level change.
And
It's a sea level change. It's a fairly rapid sea level change that happens during.
It's not a sink. I've heard that as these islands move to the north and west, they also sink. And that's why the islands in the northwest are smaller than the islands in the east. Is that consistent with what you know?
Oh, you're the one stealing my iPhone. Yeah, go ahead. Go ahead, I'm sorry.
I've heard that as this platelet moves to the north and east, it sinks, and that's why the eastern, or the western islands are smaller than the eastern islands. I was wondering if that was, I've heard it's not erosion so much as sinking.
Yeah, it does. You're right. Yeah, that's what I've heard.
Jerry has a question. If you do own land on a volcano and it sinks into the ocean, do you still own it?
Ownership is a questionable
Still have your
concept.
title.
Access is a little problem. Access is, these guys that we did this tour with, on lava flow, have a house out there that they owned a house out there and it got wiped out by a lava flow, and then they rebuilt the house. Now the lava flow is within spitting distance of their house.
Oh, wonderful. Some people never learn.
I have a comment about the Hawaiian language. You gave us a few samples of the Hawaiian language. I don't know if you saw that article a couple months ago about the linguists who determined that the older a group of languages is, the more sounds they have in that language. And they found that the oldest languages, the ones with the most sounds, are in southern Africa and western Africa. And then as migrations radiated out from there, you get languages with less and less sounds. And the language they said had the least sounds of all known languages is Hawaii, which is consistent with it being one of the last places settled in the migration out of Africa.
Oh, really? That makes perfect sense.
And that's why there's so many of those repeated vowel sounds. They don't have that many sounds in the language.
Very interesting.
Along the way.
That's
They have a limited amount of syllables.
Limited amount of
Well, thanks for coming. And next week we're at Coffee Cats.